Hi everybody, today I'm going to be teaching you about how to graph linear equations. And before we get started, I just want to go over some vocabulary. If you take a look at the word linear, you see it has the word line right in it. So everything we'll be graphing today will end up being a straight line. And equations is just when you have a mathematical statement that has two expressions equal to each other. Okay, so there's three different ways that we usually see equations of lines represented. Okay, the first of which is called Slope-Intercept Form. And you can see that's probably the one you're most familiar with, y equals mx plus b. M stands for the slope, and b stands for the y-intercept. So if you think about a straight line, and remember lines continue forever in both directions, it's only going to cross the y-axis once. Okay, so that will be, wherever that point is, will be our y-intercept. And then we also have point slope form. Y minus y1 equals m times x minus x1. You'll see again we have slope m. And then we also have this x1, y1 business going on. And all that is, x1 comma y1 is just any point that's on your line. So don't get confused by the small ones on the side here. That's called the subscript. And that's just referring to one of the points on the line. Later on, we'll be dealing with 2 points, so if we had a second point, we would refer to that as x2, y2. So this small number 1 over on the side is just to let us know that refers to the first point, and if we had other points, we would call them the second point, the third point, and so on. And so we would just have 2's and 3's here instead. And then the third form is called standard form, ax plus by equals c, where a, b, and c, so these coefficients here, are just integers. And doesn't mean a lot to you if you don't know what an integer is. And surprisingly, a lot of people don't know, but it's simply a whole number, which we know is 0, 1, 2, 3, 4, 5, and so on. But it also includes their negatives. So now we're including -1, -2, -3, and so on. So if I asked you is -17 an integer? The answer would be yes, because it's the opposite of a whole number. Is 1/4 an integer? No, because 1/4 is not a whole number, or it's negative. And also, a is typically going to be a positive number. So we'll look at some of those cases later on. But let's just go ahead and get started. Say I asked you to graph y equals 2x minus 3. Now, if you remember, that's in slope-intercept form, y equals mx plus b. So this number right here, the 2, is going to be our slope. So now we know that the slope is 2. And then, remember, over here is our y-intercept. Okay, now it's alright that it's a negative, that's no problem. That always responds to an ordered pair, 0, comma, whatever that number is. -3. When we actually go to graph, we're really going to start at the y-intercept. So you want to start at that point. It's always going to be 0, comma, whatever that number is, whether it's positive or negative. In our case, it's negative. So I'm going to start at the point 0, comma, -3. Okay, so I just go ahead and start by putting a dot at 0, comma, -3. So I go down 3 units. And just put a dot there. That's a point on your line. And now all I have to do is follow the slope. And slope, we always want to think of slope as a fraction. So 2 is not in fraction form right now, but how could I write 2 as a fraction? If you said just put it over 1, you're right. So if I just write it as 2 over 1 instead of 2, or think of it in my head, because eventually we're not even going to write this out. We're just going to do it in our head. The numerator will always tell you how many units to go up or down. Up or down. While the denominator always tells us how many units to go to the right or left. Now, how do you know which it is? Well, if it's positive, you're going to go up. If it's negative, you will go down. Same thing down here. If it's positive, we go right. If it's negative, we go left. I personally always put the negative in the numerator so that I only do up or down, and then the denominator always tells me to go to the right. But that's a personal preference, so you can do as you choose. So in our case, this means at a slope of 2 means we're going to go up 2 units and over to the right 1 unit. And I start at my starting point that I already have, and now from here I'm going to go up 2 units to the right 1 unit. And then I just repeat that a few more times. Up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And now you can see that I have all my dots in a straight line, besides these 2 strays that I made. And then I'll just go ahead, take a ruler, connect them as best I can. When you're drawing a line, you want to put arrowheads on both ends because lines do continue on forever. And it's always a good idea to label your line. There it is. So we have now just graphed y equals 2x minus 3. Okay. Now, the only way that it gets a little bit trickier is dealing with fractions, but that's really not that bad either. I'm going to apply the same logic as I did before. So we're actually always going to start with the y-intercept. So can you tell me what that y-intercept is as in ordered pair? If you said 0, 1, you're correct, because it's always 0, whatever that number is. And then our slope is always in front of the x. So our slope, or m value, in this case is 2/3. And remember what we said up here. The numerator tells me up or down, and the denominator tells me left and right. So what does the slope of 2/3 really tell you to do? I'm going to go up 2 units to the right 3 units. Okay, we'll do an example in a minute where we have some negatives, so we switch it up a little bit. But again, when I go to graph, I'm going to start at my y-intercept, 0, 1. So I put a nice dot right there. That's my starting point for the whole graph. And then I just follow my slope. So I'm going to go up 2 units to the right 3 units. Up 2 units to the right 1, 2, 3. Put a dot. From there, go up 2 more to the right 1, 2, 3. Put another dot. And keep doing as many as you can. Grab your ruler, connect the dots. Okay, and there is our graph of y equals 2/3 x plus 1. Okay, so now let's go ahead and try a few more examples. Okay, so here's one. Y equals negative x plus 4. I'm going to use the same procedure as I did before, even though this one looks a little bit different. So we can start with the y-intercept. And what's that ordered pair? It's going to be what, what? If you said 0, 4, you're correct. And what is my slope this time? When there's no number in front of the x, what number is really there? If you said a 1, in this case it would be a negative 1 because I have negative x, then you're correct. If you said 0, that's actually not going to be right, because if there was a 0 in front of the x, isn't 0 times any number just 0? So then we actually wouldn't have that term at all. We just have y equals 4. And we don't have that. We have y equals negative x plus 4. So whenever you have a variable that doesn't have a number right in front of it, understand that we always intend for there to be a 1 there. We often just don't write it. So our slope is really a negative 1. But how can I write negative 1 as a fraction? I can always just put it over 1. So I'm going to write it as negative 1 over 1. So now, this is the first time I'm dealing with a negative. What does that negative 1 in the numerator tell me to do? Remember, numerator always tells me up or down. So in this case, that negative 1 in the numerator really means for me to do what? Down 1 is correct. And then in my denominator, I have a positive number. And in the denominator, that always tells me left or right. Since it's positive, it's going to be to the right 1. Okay, so in our case, I'm going to put a dot on my graph at 0, 4, which would be right here. And then I follow my slope down 1 to the right 1. 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 And so on. Okay, connect the dots. And we'll give it a quick label. Y equals negative x plus 4. A quick way to check that at least you're right in the ballpark. Anytime you have a negative slope, your graph should be going down from left to right. Anytime you have a positive slope, if we look back at our example we just did, see how I had positive slopes here? And they're both going up from left to right. So that doesn't guarantee you that your graph is perfect, but at least you know you're going the right direction. So if this graph was going up from left to right, I would immediately know that something isn't correct. So let's look at this graph we have down here, y equals 1/3 x. Should this be going up from left to right or down from left to right? Hopefully you said down because I have a negative slope. Okay, so I'll start the same way I did the other ones. I'm going to start with the y-intercept. What is the y-intercept in this case? Normally, I have some number over here, but if there is no number, what must my y-intercept be? Remember, we always said it's going to be 0, something, so I can start off with that. Since there's nothing there, it's just a 0. So my y-intercept happens to be at the origin here. Okay? And my slope is a negative 1/3, because that's what is in front of the x. And then remember, the numerator tells me to go up or down, denominator tells me to go left or right. So in this case, if I have a negative 1 in the numerator, that means I'm going to go down, oops, let's spell down right, down 1, and then this 3 in the denominator, to the right 3. So I'll start at my y-intercept, which in this case is the origin, 0, 0. And from there, I'll go down 1 to the right 3. Down 1 to the right 3. Down 1 to the right 3. I think I can fit one more. Connect the dots. Oops. And label it y equals negative 1/3 x. And you're all set. Okay. Let's see what we have next up. Okay, how do you handle something like this when you have fractions in your y-intercept? Same way you would handle anything else. So let's start off. What is that y-intercept? Remember, it always starts out as 0, whatever this number is. And in this case, it's a negative 1/2. That's a point. It may not be on a lattice point, which is where all of these blue lines intersect. Those are nice. They're called lattice points. But that doesn't matter. That doesn't mean we can't graph it. It just means that my point is going to be in the middle. Okay? In this case, because it's a half. And let's go ahead and figure out our slope. So we talked a moment ago. What number is there if there's not a number written there? If you said 1, you're correct, and we can write 1 as a fraction by doing 1/1. So this tells me I'm going to go up 1 to the right 1. Often we get in the habit of just saying up 1/1, but you want to understand that over means to the right, if that's what we say. So I try and say up 1 to the right 1, but sometimes we just get in the habit of saying over, but over could mean to the left or the right, but just try and keep it in your head that we do mean to the right, unless that were a negative number, and in that case we go to the left. Okay, so we'll put a dot at our y-intercept. 0, negative 1/2. Well, 0, negative 1/2 is going to be right about here. Okay, so best as I can do on this graph paper. So halfway between 0 and negative 1. And now from there, this is important. If you're not starting at a nice lattice point, I have to go up 1 whole square. So I go halfway to the next box up here. So up 1 whole square to the right 1 whole square would be here. Up 1 whole square to the right 1 whole square. Oops, I made a stray dot. Up 1 whole square to the right 1 whole square, and so on. So none of these are going to end up being on lattice points, but that's okay. Alright, so if I connect these dots, there we go, and there is my graph of y equals x minus a half. Some other things you can do when you have fractions to graph and you have to graph on fractional points, you could change the scale. You just have to be really careful with your slope, because if you're changing each box, and if each box doesn't represent 1 anymore, you'd have to do your slope accordingly. But if you're not going to change the scale, just be careful about the lattice points. That is one of the restrictions of graphing by hand. Like, imagine if you had to graph 5/8. Okay, so you know it's a little bit more than a half, but it's very unclear on my graph. So graphing by hand is best when you're dealing with whole numbers for your intercepts. As you can see, in some of our previous examples, the slope isn't always a whole number, but that's okay. Having slopes as a fraction, because it just tells me how many boxes up and over. So that's the gist of graphing when you have something in slope-intercept form. So if we go back, remember, you just start at your y-intercept. It's always 0, whatever that number is, positive or negative, and then follow your slope. Alright, so if you're given any graph in this, any equation in this form, you should be able to graph it now by following our instructions. Start at the y-intercept, follow the slope. Quick checks you can always do. Remember how we talked about if your slope is positive, it should be going up from left to right. And just, it's not a bad idea. You can always plug in a point and see if it actually works, just to double check that you have the graph right. That works a little bit better when you're dealing with ones that have all of their points on nice lattice points, for example. So if you wanted to plug in, here's another point on my line, which happens to be 3, -1. If I plug in 3 for x and -1 for y, it had better work out. And luckily for us, it does, because -1/3 times 3 is -1. So that's another way that you can check that you definitely have the graph right. All the points on the graph that's what you're saying is a solution. There's really an infinite number of points all along here. Every single one of them has to work in this equation. Okay? So now, what happens if you're not given a graph in slope-intercept form, but perhaps you're given your graph in point-slope form? So remember point-slope form, y minus y1 equals m times x minus x1, where x1, y1 is a point on the line. So you really have two choices with these. You can graph exactly as it is if you understand how to extract this point from your equation and then follow the slope. Or another option that you have is to rewrite this in slope-intercept form, because this we've already gone over how to graph. It would require a little bit more work. I usually recommend it just to double check your work, because if you're given the graph in this equation, we can just extract what x1 and y1 are and then follow the slope from that point, and that's a little bit easier once you get the hang of it. So let's take a look at our equation here. So this is definitely in point slope form. So remember what we have. I think it's easiest to find the slope first. This guy out here is going to be our slope. So I already know what the slope is. I know it's 2. Or I could write it as 2/1 since it's a slope and I like it as a fraction. But then what is the x1, y1? So let's just jot that down. We know our slope is 2/1. So I'm going to go up 2 to the right 1. But what's that point? What's that? What is the, switch to orange, the x1, y1, like we had here. The x1, y1. Also note that this is minus x1 and minus y1. In my equation, though, I have a +1 where the x1 would go. That means that it's really a -1. Does that make sense? Go back to this. If I plugged in a -1 for x1 minus a negative, doesn't that turn it into plus? That's how I get that plus sign. But what must the y1 be? If you said +3, you're correct. Okay? Think. Sorry, when I was doing this before, I wrote off of the screen a little bit. So I just rewrote the problem here, and we're just trying to remember why you switch the sign when you're trying to extract the point from point slope form. So one way that might help you understand this, if you're still a little confused why this would become a -1 and why that's a +3, if I try to go in reverse. So go back to our point slope form, y minus y1 equals m times x minus x1. If I were to pretend I didn't have this equation at all, if I just took the slope of 2 and my x1, y1, there's my x1 and my y1, and I plug them into this formula, watch what happens. I'd have y minus y1, so that's y minus 3, equals m, my slope, which is 2 over 1, or just 2, times x minus a -1. So minus a -1 turns into +1. So now you can see that yes, in fact, that does correspond with my original equation. Okay? If I had mistakenly switched these two signs, I wouldn't have gotten the same equation. I would have had a plus here and a minus here. So we know that we did it right, so you do switch the sign of both. Okay? So now that I have really, this is all I need right here. I just need the slope and the point, and I'm ready to graph it. I can start at my point, which is -1, 3. Oh, we'll do it in blue. -1, 3. So I put a dot at the point that I've extracted, and then I just follow the slope, which is up 2 over 1. Up 2 over 1. Put another dot. Up 2 over 1. Okay? And I'm running out of room. I can't go any further, so I could also go down to back 1. Down to back 1 if you want a couple more points. Okay, so now this one is ready to connect. So we'll line it up. Connect the dots. And give it a label. Y minus 3 equals 2 times x plus 1. Another way that we can double check that we have our graph right is to rewrite our equation that was in point slope form into slope-intercept form. So how do we do that? Well, I have the equation right down here. So if you remember slope-intercept form, y equals mx plus b. So if I want to make it look like that, all I have to do is get the y by itself. So what I want to do first is distribute that 2. So you'd have y minus 3 equals, now remember when you distribute you have to go to both terms, so it'd be 2x plus 2. And now I would just have to add 3 to both sides. So now I have y equals 2x plus 5. And we've already gone over to how to graph this. So my y-intercept would be at 0, 5. 0, 1, 2, 3, 4, 5. Yep. And then my slope is 2. Up 2 over 1. Or I can go down 2, back 1, down 2, back 1. So as you can see, this equation, if I graph that, gives me the exact same thing as graphing it in point slope form. That's because it's the exact same line, it's just two different ways to express it. Like 4 quarters and $1 is the exact same value, it's just two different ways to have the same amount of money. Same thing here. Two different equations, but for the exact same line. Okay, let's take a look at another equation. Okay, we have one here. Y plus 1 equals -1/4 x plus 3. This one is a good example of why you really do want to get good at just extracting what's the starting point and what's the slope. Because if you think about it, if I want to rewrite that into slope-intercept form, I certainly could, but look what you're going to have to do. You're going to have to distribute a -1/4. And now it's going to get messy. I don't like messy. So if all I have to do is graph this, I know, using my point slope form, I know that I just need the x1, y1, that gives me my starting point, and then the slope. So, can you look at this equation and just tell me what the starting point is? Our x1, y1, y1. Well, the x1 would be here, and remember, if that's a positive 3, what is it really? It's really a negative 3. And then the y1 would be right here, so if that's a positive 1, what's it really? If you said negative 1, you're right. So there's my starting point. It's negative 3 comma negative 1. Okay, if there wasn't, pretend that 1 wasn't there at all, if it was just y equals that, well then, that would just be a 0 if there was no number there. Okay, so now I have my starting point, and that's really the hard part, because now the slope is not bad. What's the slope? Negative 1/4, right from there. So now I'm ready to graph. I start at negative 3, negative 1, and I follow my slope of negative 1/4. So what does that slope of negative 1/4 tell me to do? Down 1 to the right 1, 2, 3, 4 spaces. Down 1 to the right 4. Okay? I'm out of room, so you just connect these dots. Okay? And that is y plus 1 equals negative 1/4 times x plus 3. Okay? You can do the quick check. My slope is negative, so it's going down from left to right. That's a good sign. If it was going up from left to right, I immediately know that I'm wrong. Okay, so that's the gist of point slope. Again, you have two choices. If you can look at it and extract these two bits of information, you're golden. If you're having trouble with that, you can try to rewrite it in slope-intercept, but I'm telling you, it's not always easier. In this case, it would not be easier. Because if you look at my graph too. The y-intercept is not perfectly at negative 2. It's at negative 2 when x is 1. So when x is 0, I don't know exactly where it is. I know about, but it's not going to be a nice number. So that's going to be a whole bunch of nastiness that we just don't want to deal with right now. We certainly could if we had to, because we're mathematicians, but if I don't need to, don't bother. Okay, here we have two equations that are in standard form. Remember, that's the one down here where ax plus by equals c. A, B, and C are integers. So if you take a look, that's exactly what we have here. So there's not an easy way to graph standard equations that are in standard form without rewriting it in slope-intercept form. So let's go ahead and do that. And if you remember, slope-intercept is my y equals mx plus b. So all I really want to focus on is getting the y by itself. So what I need to do first is to move this entire term to the other side. Since it's a positive 4x, we'll subtract 4x from both sides. So I really have 2y, and now I remember slope-intercept form has y equals mx plus b. So the x term comes right after the equal sign. So instead of writing 6 minus 4x, I really want to write it as negative 4x plus 6, because I want that x term to come first so that I'm in the right form. Okay, and now all I have to do, I'm trying to get the y by itself. Since I'm multiplying by 2, I'll need to divide by 2. So if I divide both sides by 2, now on the left, all I have left is y. And over here, I just have to divide each term by 2. So negative 4x divided by 2 gets me a negative 2x. And 6 divided by 2 gets me a positive 3. Now this is something we've already gone over how to graph. So, since it's in slope-intercept form, I can just start with my y-intercept, which is 0, 3. And then the slope in this case would be negative 2, or I can write it as negative 2 over 1. So, when I go to graph, I'll start at my y-intercept, 0, 3, right here, and follow my slope. What does a negative 2 in the numerator tell me to do? Down 2 units, and then a 1 in the denominator means to the right 1 unit. So from my starting point, I go down 2 units to the right 1. Down 2 units to the right 1. Down 2 to the right 1. Connect the dots. And label 4x plus 2y equals 6. Okay? So down here is another one that's in standard form, so I want to go through the same steps. of rewriting it into slope-intercept form as I did above. So first thing I'll have to do here, again, I want to move that x term to the other side. So I'll subtract 3x from both sides. And now, here's a common mistake. A lot of kids just write 5y on the left-hand side. But it's not 5y. There's still a negative there. It doesn't go away. So we have to write it as negative 5y equals, and then remember our trick. I want this term first. So I write it as negative 3x and then plus 10. Okay? And it's plus 10 because that 10 is a positive. If it were a negative 10, I'd have a minus 10 on the end. Alright, so now again, I'm almost there. I'm multiplying by a negative 5. So to undo it, I need to divide by a negative 5 on both sides. So now on the left-hand side, I'm just left with y. And now on my right-hand side, remember you have to divide into every term. Well, negative 3 divided by negative 5 is not so nice. I don't have to turn it into a decimal. In fact, I don't want to, because remember, it's a slope. And I almost never want my slopes as decimals because it doesn't really make sense. I can just simplify that fraction, a negative 3 over a negative 5. The negatives are going to cancel out because negative divided by a negative is a positive. So just leave it as 3/5 x. And then positive 10 divided by negative 5 is a negative 2. So there's my equation that I need to graph. And again, we already know how to do this. So we'll start with our y-intercept, which is always 0, comma. In this case, it's a negative 2. And then our slope, already in fraction form, is 3/5. So we'll start at 0, negative 2, which is here. And then from that point, I follow my slope. That slope that indicates for me to go up 3 units to the right 3 units. So I'll go up 3 and then over 5. Okay, and I'm out of room to do it again, so I can go back to my starting point and do the opposite of both. Go down 3 to the left 5. Alright, and then connect these dots. And label my graph 3x minus 5y equals 10. Okay? And then there's only one other type. We have gone over how to graph each of these 3 now, but believe it or not, there's another type I want to look at. What if I just asked you to graph x equals 3? How do you do that? Think about that for a second while I set up the axes. And we're going to do another one down here, so I'll just make that at the same time. What would that graph look like? X equals 3. I'll give you a hint. It is a line. A lot of kids just think it's a point, but it's not. Okay. So, if we're dealing with x equals 3, let me start off by asking you, well, where is x equal to 3? Well, remember, here's my x-axis, here's my y-axis. So most of you will be able to tell me, okay, well, here's when x is 0, x is 1, x is 2, x is 3. So let's put a dot where x is 3. Okay, well, let me ask you this question. If I were to ask you about, I don't know, say this point right here. That point has the ordered pair 3, 5. Isn't x still 3 at that point? It is. No, I don't care. I don't have anything going on here with the y's. I don't really care what y is, but isn't x also 3 at this point? Is x also 3 at this point? In fact, x is going to be 3 at every single point on this vertical line. Okay, so the graph of x equals 3, or x equals any number for that matter, will always be a vertical line. Vertical line. Okay, I know it's confusing because you're thinking the x-axis is horizontal. So students always want to draw x equals 3 horizontally, but it's not. You got to think to yourself, isn't the value of x 3 everywhere on this line? Yes, so it's always going to be a vertical line. Always, always, always. So Let's just graph real quick. If I asked you to do like x equals -1, what's that going to look like? Hopefully you said it's going to be vertical, and all I have to do is make a vertical line when x equals -1, which would be right here. So let's just label these real quick. So the blue one, x equals -1, and in orange we had x equals 3. Okay? So x equals any number is always a vertical line. Always. Alright? So let's jump down to the bottom. Take a crazy guess what I'm going to ask you about here. Y equals 4. Guess what that's going to look like. So again, I have my x and my y axes. Well, the same idea. Y is 4 right here, and it's also 4 here, and here, and here, and over here, and way back here. Wherever you want. Anywhere on this horizontal line, y is going to be 4. So, in other words, the graph of y equals any number is always horizontal. Okay, and how do we remember horizontal means sideways? Because it's like the horizon. Remember the sun with the horizon? Alright. So, like the horizon, a horizontal line is side to side. So, very quickly, let's just graph, let's do a negative. How about y equals -2. So I just go down to where y is -2, and it's a horizontal line at that point. Okay, so that about sums it up. So there's how to graph an equation of line given in any 3 of these forms, or very commonly you will see just x equals some number or y equals some number. Please just always remember that x equals some number is a vertical line. Y equals some number is horizontal. Thanks so much.